All right, let's dive right in. When you're building a truly mission-critical application, your choice of database, well, it isn't just a technical detail. It's literally the foundation your entire strategy is built on. Today, we're going to figure out how to choose that foundation on Google Cloud. Because believe me, getting this right is everything.
I just love this quote because it gets right to the heart of it. Your database isn't some passive bucket for storing data. No way. It's the definitive record of value. It is the single source of truth for your entire business. And when you're talking about things like financial apps or global transactions, if that ledger is wrong or even just a little bit slow, the consequences are immediate and they are severe. And that's what brings us to this idea of the sovereign ledger. We're not just talking about storage anymore. We're talking about building systems, especially in finance or other highly regulated industries, that demand incredibly specialized architectures. These things need to handle global scale while guaranteeing, and I mean guaranteeing, that every single transaction is perfectly consistent.
So yeah, we're moving way past the simple idea of just storing stuff and entering the fascinating world of distributed systems. For the really important workloads, like a trading platform or a global inventory system, you absolutely need a database that's been designed from the ground up for crazy high availability and total correctness, no matter where your users are in the world. And that's the exact challenge that GCP sets out to solve.
But this is where every single architect hits a wall. It's this fundamental dilemma. And it's not a problem that's unique to Google or any other provider, not at all. It's a core challenge that's baked right into the very physics of building systems that are spread all across the globe. And that right there, that is the billion-dollar question, isn't it? How do you get all three of those things at the exact same time? Well, the short answer is you can't. And understanding why you can't is the key to making the right choice. This leads us straight to a foundational law of computer science.
Meet the CAP theorem. Seriously, think of this as a law of physics for distributed data. It basically says you can pick any two of these three guarantees. Consistency, which means everyone sees the same data at the same time. Availability, which means the system always gives you an answer. And partition tolerance, meaning it keeps working even if parts of the network break. Now, in today's cloud world, you can't ever sacrifice partition tolerance. So the real fight, the real choice, is always between consistency and availability.
So for decades, this was the classic, painful trade-off. On one side, you have your traditional databases that put consistency above all else. They guarantee you're getting the correct, most up-to-date data, but they might become unavailable for a moment to make that happen. Then, on the other side, you have most NoSQL databases. They prioritize availability. They'll always answer the call, but sometimes they might respond with slightly stale data. That's a concept we call eventual consistency. For years, this was the tough choice every architect had to make.
Okay, so with that law of physics hanging over our heads, how does Google Cloud approach this dilemma? Well, instead of forcing a one-size-fits-all solution, GCP gives you a whole specialized arsenal of databases. The philosophy is actually pretty simple. You match the engine to the mission, whether your top priority is latency, scale, or, you guessed it, consistency. And this cheat sheet really lays it all out. When you're dealing with global financial transactions, where every cent has to be accounted for in real time, you reach for Spanner, no question. For your more traditional stuff like a managed MySQL or Postgres database, you've got Cloud SQL. When you're dealing with insane amounts of real-time data, like from IoT devices or market feeds, and you need that sub-millisecond performance, Bigtable is your go-to. For syncing your app state in real time across phones and laptops, Firestore is the perfect serverless choice. And of course, for analyzing massive datasets, you've got the beast that is BigQuery. It really drives home that right tool for the right job approach. And that brings us to the main event, Spanner. This is Google's answer to that architect's dilemma we've been talking about. It's built for those workloads that simply cannot, under any circumstances, compromise on consistency, even when they're operating at a truly planetary scale.
Now this is the core claim, and let's be honest, it's a massive one. Spanner is engineered to give you the best of both worlds. You get the rack-solid consistency of a traditional relational database, but with the incredible scalability and availability you expect from a modern cloud-native service. It's basically promising to solve that classic, painful trade-off for the most demanding applications on Earth.
So how on earth does Spanner pull this off? Well, the secret sauce is something called external consistency. This is an even stronger guarantee than what most databases even try to provide. Just imagine a stock trade in New York and a user updating their profile in Tokyo happening at the exact same millisecond. External consistency acts like a universal referee, ensuring the system processes them in a single, definitive, global order, as if they happened one after another on a single machine. There's no ambiguity, ever, and that is what makes it so trustworthy for financial ledgers. So let's break down how this magic actually happens. First, synchronous replication. When you write data, Spanner doesn't just say, "Yep, got it." Oh no. It makes sure that write is safely copied and committed across multiple regions before it even thinks about giving you the thumbs up. Second, it uses a quorum system, which means a majority of copies have to agree on a write, guaranteeing it's correct even if a whole data center goes offline. And third, a disaggregated architecture. Think of it like separating a factory's brain from its warehouse. The compute, or the brain, and the storage, the warehouse, are totally independent. This allows for crazy fast scaling and failover. This powerful combination is how Spanner delivers on its incredible promise. So, let's bring this all home. We've gone from the fundamental laws of distributed systems all the way to the specific tools the GCP offers. The takeaway here should be crystal clear. Your choice of a database isn't just about technology, it's about strategy. Let's quickly recap the absolute crucial points. First, your database is your ledger of truth, period. Its integrity is everything. Second, the CAP theorem isn't a suggestion, it's a law, and it forces a choice between consistency and availability. Third, GCP gives you a whole matrix of options so you can match the tool to the mission. And fourth, for those massive, planet-scale apps that need both consistency and scale, Spanner offers a truly groundbreaking solution. Always remember, choosing your database is choosing your strategy. So, the ledger is set for our new cloud-native world. But what do you do with those massive, critical Oracle databases that are still running so many of the world's biggest companies? Well, in our next explainer, we're going to build what we call the Legacy Bridge, and we'll dive into how to bring those Oracle workloads into the Google Cloud arena. You are definitely not going to want to miss that one, so be sure to subscribe.